Let's start with temperature. At least twice in the last billion years, the Earth was a ball of ice from pole to pole. The oceans froze over. Each of these periods lasted about 10 million years. In the last 600 million years, the Earth has been mostly free of ice at the poles. In fact, permanent ice at both poles has occurred less than 10% of the time. Now, because we really don't know, I'm going to choose 16 degrees Celsius as the point where the North Pole no longer has ice over summer. We're at about 14.5 degrees now. Here's what we know about CO2 during this period. What's the trend? What are the drivers? It's hard to see any correlation here. Notice that CO2 was as high as 7,000 parts per million during the Cambrian period when there was an explosion of plant and animal life. This may not be accurate, but it is the best data we have. Let's zoom in. Looking at the last 400,000 years, we see a distinct cycle driven by the sun. The Earth's distance from the sun and its angle of rotation create so-called Milankovitch cycles of cooling and warming. For the most of the last 400,000 years, we've technically been in an ice age, with ice at both poles year-round. Now let's add carbon dioxide. This data comes from ice cores. If you look closely, you'll see that CO2 usually follows temperature. There's a lag of between 100 and 800 years, which you can see by noticing that the gray lines are usually a bit to the right of the red lines. The simplest explanation is that CO2 is not the cause, but rather the effect of warming. Now, there are more complicated explanations, but the simplest one is often the best. 20,000 years ago, New York City was under a kilometer of ice. Since the end of that ice age, there was a cold period at around 13,000 years called the Younger Dryas, and then something interesting happened. Climate has been remarkably stable, all by itself, for about 10,000 years. It should be clear that humans have had nothing to do with this. Now again, let's add CO2. And once again, we see the time lag. It's very difficult to see CO2 as the driver of climate. In the last 1,000 years, all the data point to a pronounced warming period in the Middle Ages, when Greenland was inhabited and farmed, followed by an ice age when the Thames River was frozen over during winters and Greenland was abandoned. The Little Ice Age continued until about 1800, when temperatures started going up. Looking at CO2, is CO2 driving temperatures? Let's zoom in again. Because of the European wars, the best historical thermometer data comes from the United States Historical Climate Network, which we use as a proxy for the Northern Hemisphere. I want to take a minute to break this chart down into 4 separate periods. A hot period, the 1920s, 30s, and 40s, during which there were extended heat waves and droughts. The next 30 years were cooler, and there was talk of global cooling. The New York Times reported many times that scientists agree the world is getting colder. Then another 30 years of increasing temperature, including a serious El Nino in 1988 and then the big one in 1998. And that performance hasn't been repeated. For the past 20 years, despite another El Nino in 2014 that drove the press to claim the sky is falling, the average temperature in the U.S. hasn't risen much at all. Not one of Al Gore's predictions has come true. In the last 100 years, U.S. average temperature has increased less than 1 degree. Yet in 2006, Al Gore predicted within the decade there will be no more snows of Kilimanjaro. Well, this is how Mount Kilimanjaro looks today. Some of the ice on the Kibo summit is still 40 meters thick. Al Gore made his predictions based on photos taken by his friends. Let's look at the data instead. Kilimanjaro's summits have lost a lot of ice in the past 100 years. Researchers Philip Mote and George Kaiser explain that the loss has nothing to do with temperature because the temperature on the summit hasn't changed. Rather, it has to do with less rainfall since the late 1800s. Most of the decline happened before 1950. It's still possible that the snow on the top of Mount Kilimanjaro will disappear, but the fate of most tropical glaciers is determined by precipitation, not by temperature. Back to North America. Let's add CO2. Now we know CO2 has increased during this period from 280 parts per million to 400 parts per million. If that's driving temperatures, we should see an upward curve in temperatures over the past 50 years. In this time period, we have accurate satellite measurements, so we can look at the global picture again. This much more accurate record shows a long-term rise of about 1/10 of 1 degree centigrade per decade for the past 5 decades. Very much the same pattern we've seen for the previous 150 years. Plenty of variance and a steady increase of 1 degree Celsius per century. It's tempting to think that CO2 is driving temperatures up, and it may actually have some effect. But in reality, it may just be driving thermometers up. And to understand that, we need to learn how we measure temperature.